So let's say in here first what are our objectives for lesson 3.3 on power and polynomial functions. Okay, Kaden, let's read this one in here.
Identify power functions, identify end behavior of power functions, identify polynomial functions, identify the degree and leading coefficient of the polynomial function.
Thank you, right? As you may notice in here, it's basically what? Identifying, right? So there's no need to solve algebraically for anything, all right? So basically identifying whether they're power functions or polynomial functions, and actually how to use the degree, right? And the leading coefficient, whether that be positive or negative, of any function, power or polynomial function, to determine its end behavior. In short, how does it behave on the right end and on the left end of a polynomial function, right? But before that, let's see first what are the definitions of a power and polynomial function. Okay, Marguerite, let's read. What is a power function? Go ahead. Thank you.
A power function is a function that can be represented in the form f of x equals k of x by the power of p.
Thank you, right? And as you may notice in here, k, p are real numbers, and k is known as the what we call the lead coefficient, right? Yeah. And when you say the lead coefficient, that's basically the number in front of the x with the highest degree. Are we good, right? And the p in here is basically called the degree of your power function or polynomial as well, right? That's the highest exponent of your function. Are we good? Right. Let's see now. Any questions with our power function? Now let's see, what do you mean now by a polynomial function, right? So here is what we call a polynomial function, and see how different that one is from here, okay? What is a polynomial function? Victor, can you read it for us, please? Thank you. Yeah, a sub n, x to the n, right? There you go. Thank you. And continuing, right, until a sub 0, continue. This is called, yeah. So at the bottom, it says what this is called. What form is that? Very good, right? Are we good, guys? So once again, the same in here. Thank you for that, Victor. The a sub n in here is once again the lead coefficient. Let's call it LC, the lead coefficient. And the n in there, right, is the degree, right? The highest exponent of your polynomial function, right? Are we good? And again, as you may notice, we keep on mentioning the lead coefficient and the degree because we're going to use those two to determine the end behavior of any polynomial. Right? Well, first of all, let's see first which among these is a polynomial and which one is not a polynomial. All right, let's read this one in here. Numbers 6 to 11. Let's read that one. Emma, go ahead. Yeah.
For the following exercise, identify the function as a power function and polynomial function ratio.
Thank you. Right. So among these in here, which among these is a power function? Look at those. Which among those is a power function? And what do you think, guys? Reagan, what do you think? 6, 7, 8, 9, 10, 11. Which among these is a power function? 6, very good, is a power function. Let's call it pow. Actually, number 7 is also a power function, right? It's basically x to the 6th power. Get it? Right? By power rule. Are we good? Right. Next one. Which among these is a polynomial function? Polynomial function. Thomas. What number? Number 10. Very good, right? So sorry for that. Let me just rewrite it for you guys. Here it is, right? Yeah, that's a polynomial function. Again, for a polynomial function, just look at the degree. The degree is what? By product rule, the sum of all the exponents, right? This is exponent 1, right? That is exponent 1, this is exponent 2, so that means in here the degree is what? 4. Okay, yeah. In some cases, it's also called a quartic function. Get it? Again, it's also called a quartic function in math terms. Okay, now with that being said, let us see now in here a table analyzing the end behavior of polynomials. See this end behavior, guys? All right, so notice in here, it depends on the degree of a polynomial, right? So if it's degree, say what? Let's say this one. X squared minus 2x. Right? Very good. So that's what? Even degree, right? Let's say this one is what? Negative x to the 4th plus 7x cubed, right? So still a degree 4. Very good. That's even power, right? What about an odd degree? So, for example here, can you give me an odd degree, guys? Evilai? X to what odd degree? Odd. 1. What else? Well, we want a polynomial, right? Because 1 is linear, right? So we want something that's more than 1. What's the next to 1? 3. There we go. Get it? Yes. Get it? X cubed, for example. X cubed minus 5x. Yeah. What about this? Well, any odd degree as well. Negative lead coefficient, for example, negative x to the, say, 5th power, right? Yeah. Plus 8x. Are we good? Right. So, odd degree, x cubed, x 5th, right? Yeah. Even degree, x squared, x 4th, right? What other even degree can you think of? Aiden? 6, x to the 6th power, right? What odd degree can you think of? Anna? What odd degree can you think of? Other than these two?
7.
X to the 7th power. Very good. Get it? All right. Also, as you may notice, lead coefficient. Look in here. What's the lead coefficient here? 1. Right? What's the lead coefficient here? 1 as well. Right? So both are positive. Right? In here, the lead coefficients are what? Negative. Are we good? Right? Now, what do we notice? Here it is. Right? Notice that if your lead coefficient is positive, right? If your lead coefficient is positive, positive 1, what do you notice about the right end behavior? As your x goes to the right infinitely, right? Where's your y going? Up or down? Up. Very good. Right? So as you may notice, this goes up and that goes up. Very good, Eva, right? As x goes to infinity, your y goes up to infinity as well, right? On the other hand, if your lead coefficient is negative, what do you notice on the right end? Okay. Right end. They're both going down, right? As you may notice in here, as x goes to the right, your y goes down to both of them. Are we good? Now, what do you notice now about the odd degree? Look at the odd degree. And let's read this one in here. What did it say? All right. Anne-Marie, let's read this one. Left and right.
Left and right is opposite
Direction for y, right? So as you may notice, if your left goes below, your right goes above. We good? They're opposite direction for y, right? As your left goes above in here instead, your y goes below, right? So they're opposite directions, all right? Now let's notice on the even degree. What's noticing in the even degree, all right? Kylene, can you see it from here? In red?
Left and right are the same direction for y.
Thank you, right? Noticing here, the left and the right, they're both going up, right? For negative, the left and the right, they're both going down. Are we good? Well, let us analyze the end behavior algebraically of such. And again, you can actually do this one by graphing it as well, right? But algebraically, let's just see in here how to get the end behavior of such, all right? Giselle, can you read the instruction for this?
For the following exercises, determine the end behavior of the function.
Thank you, right? Let's answer number 21, okay? Ready? Number 21. The end behavior of this. So how do we analyze the end behavior of this? Well, first, what is the leading coefficient?
Negative.
Positive or negative?
Negative.
Negative. Very good, right? So it's negative 2, right? So that's a negative. Get it? Okay. Next, what about its degree? Is it odd or even degree, right?
Even.
McKinsey. Odd or even degree?
Even.
Even, right? So with that being said, what part of this one will that be, right? What's that again? Negative lead coefficient, even degree, right? Where is that? Even degree, right? Negative lead coefficient. So this one in red. Are we good? Get it, guys? Okay, this one in red, right? Negative lead coefficient and even degree, right? What did it say? Well, it says in here that the right end, right? So right end first, right? How to analyze. So you start first with the right end, right? So the right end, since it is negative lead coefficient, means what? As x goes to infinity, where's your y going to? Up or down?
Negative.
Negative infinity. Very good. Get it? Again, simply because this is what? Negative LC, right? Negative lead coefficient, right? Now, what about the left end? How do we analyze the left end in here? Well, we analyze that one from stating that since it is even, then that means the right end and the left end should be what? Opposite or same directions?
Same.
Same directions, right? So in short, in here, the left end is same as the right end, right? They're same direction, right? So with that being said, for y, by the way, so as x goes to left, your y also goes down as well. Are we good? Right? Okay. Even without graphing it, we can already, have a view of how it looks like. It should definitely look like this. We good? Yeah. That the left end, as x goes to negative infinity, your y goes to negative infinity as well, right? And on the right end, as x goes to infinity, on the right, your y goes down as well. Are we good? Right? And again, verify it by graph.